Hi there, this is Christian Hoffmann speaking from Trimble. Happy to have you all around here for our webinar on TBC calibration registration topics. I would like to introduce you to my colleague Bishoy Gerges, who is also with me, and he will take care of questions and answers. So Bishoy, maybe say quickly hello.
Hello everyone.
There he is,
I
yeah,
think
just checking.
audio and video coming good.
Okay, perfect. Thank you. So let's start. Let's have a quick look at the agenda. It's under what we call the Mobile Mapping Essentials webinar series, which is something we're doing during this crazy times of this coronavirus. And even while things seem to be getting better a little bit, there's plenty of us in this home office mode. And actually, we found out that this is a great way to present some of our stuff to interested people. So today, talking about calibration and registration. So quick introduction, looking a little bit into the workflow, and then talking you through some details here. Some housekeeping before I continue. I would also like to announce the technical webinar that goes along with this essential series. In this case, so there's a technical webinar series as well. Some people of you probably joined this as well. This is actually done by Bishoy and his team, which is the mobile mapping support team. They'll do a session on the same content on June 16th. It's a morning and an afternoon session, and that goes really crazy on the technical details. As I'll be talking you through it more in a generic way with slides. And this session, if you're interested, really goes into the details, also using some examples out of the software or Bishoy taking care of this inside of TBC. All right. So introduction and workflow. To start with, Trimble Business Center, or TBC, is our software of choice for mobile mapping data. That's where you process all the data and prepare the mobile mapping data to be used somewhere else, whether it's inside of TBC, which is our big survey software platform, or whether you go to our product that is more geared towards GIS deliverables, which is called Trimble MX, or any third-party software of your choice that you might want to use for mobile mapping data. But in this TBC mobile mapping, we do have a module which we call TBC mobile mapping, or TBC as you can see the abbreviation here. And this is for all the data processing and making the data accurate, good, clean, so it can be further used. And there's one new feature that we've integrated just lately in our 5.30 release, which is the calibration of the MX9 hardware, whether it's laser data or whether it's the laser sensors, I should say, and the camera. So there's a calibration feature we introduced today as well. Now, quick catch up on the workflow, just in case somebody has not seen that workflow. We typically look into this from a field to finish point of view, collecting data in the field, processing the data so it's ready to be used for data or feature extraction, doing that extraction and then further analysis, modeling in a CAD software, or then finally publishing the data. So you can see various, I could say, tracks, whether it's the TBC track, the TMX track that I've mentioned, which typically dealing with an ArcGIS or QGIS kind of system of reference, so the data going into these environments, or a typical CAD design, BIM, whatever software in that respect, Revit or something else, typically being used by our customers. So that's where the data ends up. And also there's the non-Trimble track in green, where actually you could see other tools that are being used for information extraction. But today we're going to look into the registration and calibration component. So I just wanted to remind you of where in the workflow this action is taking place. So calibration, brand new feature that we've just released. And I'd like to start in this sequence of why, what, and how to make it clear actually why we do this, because we could talk forever on technology, but actually why do we need to do that? A recalibration is necessary after changing a laser or changing the laser's orientation. As you may know, the MX9 can be tweaked in such a way that both lasers can be put into 3 horizontal and 3 vertical positions, so 9 different positions. And after this change, you would need to do a calibration. So what is this all about? It's calculating the bore side angles so that the laser data matches to each other and to an absolute reference. How do we do that? Well, first of all, we got to collect some data in the field that's good for calibration, which you actually can see in this screenshot at the upper right side here of the slide. We're looking for a 90-degree cross section where you actually take a couple of runs, at least 4 runs, and they are then used for this automated calibration. So this tool is running fully automatic inside of TBC mobile mapping, and then calculates those bore side angles and also presents residuals that can go into a calibration report. And then finally, you're actually updating your system with this new calibration, or just apply this new calibration to previously recorded data. Either or is possible. Camera calibration, why, what, and how. So why we have to recalibrate the same way then with the lasers if you're changing the camera orientation or replacing a camera. Same thing that like the lasers, the side-looking cameras can be changed in its orientation. Then this camera calibration is necessary, which calculates the bore side angles, and the camera data matches the laser data, which you actually can see on the right side. On the upper image, you can see a point cloud and the imagery, and it's not fitting. And after the calibration, it's fitting. And then, it's calibrated data that fits on top of each other. How we do that? Same approach. Go in the field, collect some calibration data. The tool is more manual, but it's easy to use. That's a nice way. You can use arrow keys, then actually you shift the images or change the orientation of the images on the fly using the arrow keys until you're happy. And this is then the bore side angles that you will use. And then same way, you can then update your system with this new calibration, or just apply the calibration to previously taken data that's already in the office. Registration. So again, why, what, and how? So why do we actually need to do a registration? In mobile mapping, there's always some offsets due to the occurring GNSS errors. It's something you can optimize a project. You can try to make it in such a way that you get as less error as possible, but you can't avoid it. Whether that is through a tunnel, whether that is in urban areas where you get some occlusion by buildings, the chances that you get some GNSS error is there. So in order to get to a correct absolute position, you got to do some absolute registration. And it's of course totally dependent on your project requirements. If a project is requiring a 1 to 2 centimeter accuracy, then this is typically something where you would need more efforts to register your data. And when it's fine with a 10 or 20 centimeter accuracy, which is typical in an asset management workflow, this might be fine, where the absolute precision is not that important. And furthermore, we do this not just to get this absolute reference, but also to get a relative alignment between different runs of your project. So think of, there's a highway where you drive 2 lanes in parallel, or 1 lane up, 1 lane down on in a urban area roadway. So that data fits, you gotta do this registration or this co-registration, so the data fits on top of each other. And that's the 2 modes we offer in TBC mobile mapping: a registration of runs to control points, or a co-registration of 1 run or a number of runs to a reference run. So how we do this, that is, I'm showing you a couple of details. That is the TBC mobile mapping registration tool for these operations. So registration to control. So control points typically surveyed with traditional methods. You bring them into TBC, and there are different things you can choose from. There is a local, global, or a local and global registration approach. So dependent on whether you get a global offset that you want to correct for, or whether you have just a certain specific area of your project, maybe that's an urban area where this local control is required, you can choose from different ways to register your data. Then once you know what you want to do, the way to do it, we've actually enhanced TBC mobile mapping quite a bit over the last few releases with this smart picking tool. It's very efficient and precise way to measure your control points on the screen, and then do the registration with these very accurate measurements. And then after doing so, there's always the question about quality control. So the residuals are presented and then are available for reporting, or they will go in the report that can be generated with the click of a button. To put a little bit more flesh to the bone, some screenshots to illustrate that a little bit. So this is registering to control. You can see on the left side, there's a checkerboard control point that is being used. You see the interface. There's a drop down that you can see here for local, global, and global, then local adjustment, illustrated here by these different graphics. Here's a good reminder of the webinar that we are planning, the technical webinar that we're planning with the support team, because here the team will guide through the technical details. How, just on the technical details. So that is some idea how this is done. Now I've mentioned this smart picking tool. So have a look at these screenshots. There's 2 different targets on the left and on the right side. That's illustrated in the middle here with this checkerboard and the pure reflective target, which is a typical way targets are designed. So with the checkerboard, you're trying to aim for the middle, which obviously you can point to. For the purely reflective target, which is typically something people do using reflective paint sprayed on with a pattern, you cannot just measure the center. So it's more that you have to measure the outline of that target. But then the center point, typically marked with a nail or so, is then being used. So have a look at left and right side, how the tool performs dependent on the target. You can see there's in X, Y, there's different ways to find the center point. So this is kind of an interactive way to measure your target. And then for set picking, there's the right side of this little window where you also can make sure that you're picking really the right set coordinate and not maybe an outlier that is 10 centimeter above or below. If it's like a manhole, sometimes the point cloud goes under the surface. So if you're picking the wrong set, that of course would not be producing good results. So then we've split up this target picking into an XY picking and set correction. And that's the way to measure very accurately on screen the targets. One additional feature is the use of what we call validation points. So in the same way you measure control points that you use for your registration, you can also mark these points as validation points. Then they're not used for the actual registration, but residuals are calculated. So you get independent statistics at points where there's no registration force, so to say, being applied, but it's just a validation point that is kind of independent from the algorithm pulling data on top of each other. Excuse me for a second. Now, coming to run registration. So this works in a different way. This is an automatic way to register a run to a certain reference run that you pick. So typically you pick one run that is very well aligned or registered. Maybe that registration was done with a number of control points, and then you're actually using an algorithm to match other runs on top of that point cloud. That actually comes from our terrestrial scanning. So this is something that has been worked on for many, many years in the terrestrial scanner world. And this algorithm performs in the same way very accurately on mobile mapping data. So this then is used to adjust the trajectory based on the matching results. So it's not just dragging the one point cloud on top of each other, it's actually going back to the trajectory and then adjusting that trajectory and recalculating the point cloud so that, yeah, all the data matches, but is still aligned to the trajectory. And then again, residuals are presented and also available in the reporting. So in that reporting, if you register multiple runs, for each run-to-run registration, you would get an extra table with residuals, so you can do full quality control of that procedure. Just some screenshots to illustrate what's meant with run-to-run registration. So you can see here on the left side, that's a road surface that was taken, and after the run-to-run registration, it's really fitting nicely on top of each other, whereas without that, there was still some offset that was seen. And the same way, this road sign you can see on the upper part, especially on the frame of, you can see it somewhat better. The data is not perfectly fitting on top of each other. In the lower section, that's really nicely fitting on top of each other, and then you can have this point cloud then used for your modeling and things like that. Now already pretty much at the end, coming to this what's called mission report. So you see on the top right, there's an icon in TBC mobile mapping which simply creates and opens a report. This is just a section. You can see there's a scroll down bar. So with that scroll down bar, there's all the information available. At this point, it's generated in HTML, and you can actually copy and paste some of these tables into a spreadsheet. So if you want to do some further analysis on these, they are available with a simple copy-paste operation to a spreadsheet. Other than that, it's all presented, all the different calibration, run-to-run registration, and yeah, some other statistics, or pretty much all the statistics we can think about that is necessary for quality control and also for reporting to an end customer who always, of course, wants to get an understanding of the work that has been done. That's already all the content I've had for today. Before we start with the Q&A session, and before I hand over to Bishoy for some questions that you might have, here's another reminder of the technical webinar. If you're interested in the bells and whistles of all these tools, then join us on June 16th in the morning or afternoon session, and then we'll take it from there. Other than that, thanks for listening. I hope that was some interesting content, and I will now hand over to Bishoy for some questions or specifically for some answers.
All right, thank you, Christian. So yeah, we have received a couple of questions here during the presentation, but of course this is the right time for you to send us anything that is in your mind. We'll be happy to answer all the questions now. So please send up your questions in the questions window. All right, so we have a question here regarding postback. Does postback or is postback a module that resides inside TBC or is standalone? No, postback is a standalone product, and it's made specifically to post-process trajectory information that is coming out of the mobile mapping systems that are running the LV or MV or AV boards. These are the Applanix Trimble boards. So it's a standalone product. Another question, if it's two-lane road with parallel runs, does this run to reference run work without having any intermediate GCPs? Yes. So as long as there is a decent overlap between the two runs, then the tool will work without GCPs. So it's purely based on cloud matching from terrestrial scanning. So it's you could think of it as the tool just splits the run into some segments and then tries to fit these two segments together like it's trying to fit any terrestrial laser scan data together. All right, so another question, once calibration is computed in TBC, can it be uploaded to the MX9? Yes, definitely. So this is only possible, of course, with the new release of TBC 530. Once a calibration is computed inside TBC, you could just export the calibration file and upload it to your MX9. We'll be going, as Christian said, into more details of this on how it's done exactly and all the technical information in the next webinar, which will be coming on 16th of June. All right, so how much time does the calibration calculation take or cost? So usually this will take about 2 hours with a decent workstation. It's a very heavily computationally demanding operation that takes lots of iterations, and mathematics are done in the background. So it relies completely on the CPU, and whenever you have a more powerful station, then the lower time it gets. Are there any situations or scenarios that you have found particularly challenging with regards to calibration and registration? So, of course, there are always challenging and particularly challenging scenarios and situations. However, if you would follow the recommended instructions and the best practices, the workflow, and also acquire data in a way that we suggest that would basically avoid you all the troubles, then there should be nothing there should be no problems for that. So what should be the typical distance between two adjacent control points to get 2 to 3 centimeter accuracy? So this is a very subjective, and depending on your environment, depending on the quality of your control points, depending on many factors. And for that, we have actually done a specific webinar on registration with ground control points. So I highly recommend that you just go to our YouTube channel and revise the webinar on mobile mapping registration. There we really go into details on how to get to 2-3 centimeter accuracy or even lower. How much overlap of point clouds is recommended for a run-to-run registration? So there is not really a minimum, so it will register whatever is overlapped, as long as the trajectories are more or less parallel to each other or passing in the same direction. So even if it's just 10% that's overlapping, it will still work. It will register 10% and then the other will not work. So can you please shed some light on primary and secondary genesis importance in mobile mapping systems? So I think by that you'd mean the GAMS solution. So we use particularly the GAMS solution in challenging situations where the system is not changing its heading very much. And an example for that would be railway situation. So when you're driving a railway, you cannot simply maneuver the train as you do with the car to provide some dynamics. Therefore, you would need the GAMS for this. Also, we've addressed this particular situation and many other similar situations where you would need GAMS or other aiding sensors like the DMI. We have addressed that in another technical webinar, and this is also uploaded on our YouTube mobile mapping channel. You will find there a webinar on our best practices. All right, so lots of questions we're having here. It's good. So we have, that's a long one. So when doing run-to-run registration for several runs inside one mission, at least one run needs to be a control quality. What is the default process of making first run as control quality run? Should we need to add control points from totalization GCPs and register run to GCP, or is it possible to register run to run without any additional data? So this is a very good question, because you have the choice to do either that or this, meaning you could assume that you have one reference run without any control points. You will just assume, you'll just pick this run based on whatever, any personal preferences. You would pick a run and you would call it reference run, and then you would simply register everything. You'd register everything relatively to this run. That's one way to do it. Or the other way would be that you'd first of all make one very accurate, precise registration of run to control points, and then that run becomes your absolute right, and then you register everything also relatively to this one. But in essence and in general, a run-to-run registration doesn't require any previous steps. But of course, if we are pursuing the most perfect workflow here, then we would definitely throw some control points, and we would register one run to control points first, and then we would bring everything to this reference run. And I hope that explained or answered this question as you were looking for an answer. So are there plans to add support of rectangular targets? So I think by that you mean just adding shape to the library of or the target shapes that we have. We definitely add the most commonly used shapes, but the rest of the shapes are are just a matter of you just need to find the center yourself. So it's not like it's not supported or anything, but you might need to pick the center by yourself. But I think that's a good point that we should look into it. So maybe Christian should take this into account next time for maybe the next release as a feature enhancement. We could add support for rectangular targets. So you could define different width and length.
Yep, I'm not sure I get the question correctly, because rectangular targets would be supported, right? Or are they just squared? It's actually a good question.
Yeah, so currently we have squares only. We support squares. So whatever the checkerboard is, it's just a square. So all the sides are same length. But if we would have rectangular targets,
yeah, okay. No, I get the question and I agree.
Yeah.
Just to mention that there's always the manual picking mode. So this smart picker that we've presented helps on some of these targets that are implemented, but you can always pick a point somewhere. So it's not that it's not doable, it's just not that smart, meaning it's a little bit more work to pick such targets, but it doesn't mean that you cannot pick such targets.
Yeah, we also try to follow the most commonly used best practices. So we've always seen square targets. It's because they're just maybe look nicer or they're just easier to identify. But yeah, I mean, definitely something to consider here. All right, so another question, does the point picking for registration allow picking points on vertical surfaces? For example, assign and control. Yes, definitely 100%. It allows picking on any surface. So whatever the orientation of that surface, if it's horizontal, vertical, or anywhere in between, you definitely have the tools to pick that and pick it precisely. So you can even do all the adjustments you need in the height.
And then what I showed in the screenshot, I said it XY picking and Z picking, but that turns around then. It's pretty much taking the surface it finds, and this is defined as XY, but it could turn 90 degrees, and then you can deal with such targets like a sign, right?
Yeah, exactly. All right. So another question saying, I hope this run to reference run will support other systems data too. Not sure what it means exactly. So currently like what we have is, yeah.
I think I get the question. So that means that of course also the imagery, which is it's all sticking to the trajectory. The trajectory is suggested, then of course also the imagery fits then to the point cloud. Oh yeah, and there's a follow-up from this question. Oh, you mean other OEMs? So other systems are currently not supported. Right now, this is really the run-to-run works with our data.
Yeah.
Of course, that's an interesting request we've heard more often. So this is probably something we got to look into, but at this point, that's not supported.
Yeah. All right. Another question: how I can transform data to local coordinate system? So that's done very easily with the coordinate system manager that resides inside TBC. So we have a very powerful coordinate system manager that allows you to create and manage your own coordinate systems for anywhere in the world. Of course, it comes with a predefined library, a huge library of systems everywhere. And this library is enriched over the time. So you would always get updates. It happens very regularly, actually. So every month or two, you get an update with new systems that are added. But definitely you can define your own coordinate system there, that your local coordinate system that you would like to work with. And you just need the coordinate system parameters, the projected parameters, and you just define your own. So it's a part of TBC.
All right. Thanks, Bishoy, for all these detailed answers. That's great. And I think we're through. No
Yeah.
further questions. If there's anything else, drop us a note and mark that June 16th in your calendars if you're interested in some further technical details and getting also some insights on the GUI itself and how it's done and so on. Other than that, I would like to thank everybody for joining this webinar. Yeah, stay healthy and talk to you later. Thanks a lot.
Yep. Thank you, everyone.